Hello and welcome to another video. In this video we're going to be working on group anagrams. And in this problem you're given an array of strings and you want to group the anagrams together. You can return the answer in any order. Anagram is a word or phrase rearranged or formed by rearranging letters of a different word or phrase, typically using all the original letters exactly once. So that's kind of what you need to know, is you just need to know what defines an anagram, and it's roughly this. And the other thing for anagrams is all the letter counts are equal for both words, right? You just have a bunch of letters and you arrange them in a different way. So if we have letters like A-T-E, well, we can rearrange them like this. Maybe we can write like A-E-T. Maybe we can write like T, and so on and so on. So they kind of show you this example here, eat, and T. And there's kind of two ways to figure out what words are anagrams, and we can talk about it briefly. So one is sort the words. So if you just sort by character, you would get AAT for this word. And then if you sort T by character, you would also get AAT. So you can sort all the words, and then all the anagrams sorted will be the same word. So you can use a key of the sorted word, and the value will be the anagram. And that way, like if we go through this example here, so we get eat, which will sorted be AAT. So for AAT, we will write a value of eat. And then we get T, which sorted is once again AET. So we will write a value of T. Then we will get 8, which sorted once again is AET. So we will get 8. And nat, which sorted is ant. So we don't have that yet. So we'll put ant over here with nat and its anagrams. And bat, we don't have bat either. Sorted, it will be ABT. And we don't have that, so we'll put it in there. And so that's kind of how you do it. Then you just basically return all of your values in different arrays. So like EAT, T, and 8 will be like 1. Nat will be 1, and bat. And I forgot tan, it looks like. So yeah, so tan sorted will also be ant. So we will just put in tan. So that's one way to do it, and that's kind of like the intuitive. The other way is, for every anagram, the counts of the letters are the same, right? So for all of these anagrams, you will have one A, one E, and one T. And so now the problem is, how do we get a key out of this? Like, because the counts are the same, how do we get a key out of this? We need something to compare. And so there is a way to do it. But you want to make sure your keys are the same. So there's kind of two ways to do it. One, you can sort the letters. And now notice that if it's only lowercase English letters, like here the word is 100 characters, so this isn't the best solution. But let's say your words are like 10 to the 4th characters. Then you're going to have big letter counts, and sorting the letters is pretty cheap because there's only 26 letters. So totally fine to sort the letters. So once you sort the letters in alphabetical order, now, sorting the letters is going to be a lot cheaper than sorting a 10 to the 4th length word, right? So we get the letter counts, we sort them, and then we can just have some kind of key of like maybe character with a number, character with a number, character with a number. So it would have something like A1, E1, T1. Make this a string, and now this will be like the key for the anagram. So every anagram with this letter count will have this key. And then this key can be used to figure it out. Now, this is a better time complexity solution because you don't have to sort individual strings, but actually in this problem, this will be slower because your words are only 100 characters. So you have to do a lot here, right? You have to get the counts, you have to sort the keys, and then you have to make the strings. So this is going to be a lot more worth it if this was a bigger number. So like in theory, this will be a better time complexity, but in practice, it will actually be slower. But like I said, imagine if we had 10 to the 6th strings, and maybe a string length is like 10 to the 4th or 10 to the 5th or something, that's going to make it a lot better because sorting 10 to the 5th is 10 to the 5th times log 10 to the 5th, right? But sorting 100 is fine because it's like log 100, which is, I don't know, like 8 or something, really small number, times 100. So that's totally fine. And then you don't have to make these like counters. But that's kind of the two ways of doing it. Either sort the strings themselves and use that as a key, and then every single anagram will have the same key. or get a dictionary of all the letters and make a key out of that. This is one way to do it. There's other ways. You don't have to sort the letters, but sorting letters is cheap because, like I said, if it's only lowercase English letters, the log is basically nothing, right? Like log of 26 costs you basically nothing. Like this is basically linear time. So log 26 times 26 is linear time. So that is like an easy way to make a key. You just sort all letters. Also, obviously, if your word doesn't even have 26 letters, then it's even less. And so those are kind of the two ways. You can make keys in other ways, like you can get the dictionary and you can make keys in other ways. But the idea is you need some kind of key to represent the letter counts, and you need these letter counts. The reason you need them to be sorted or have some kind of indexing is because dictionaries don't maintain index. So like for one counter, you might get this. For another one, you might get this. And these should be the same. That's why like sorting the letters is important, because you want these to be the same thing. And you can't store a dictionary as a key in a dictionary, right? So in our dictionary, we're going to have, for the key, we're going to have some kind of thing to tell us like what bucket of anagrams this is in. But you can't have a dictionary for that. So this is just one way of doing it. I'm just going to code up the solution. I think it's more intuitive, and it's actually going to have better runtime in practice. So we can do that. So what we need is the key to be the sorted string, and then the item or the value will be the actual anagram. So we can just use a default dict here. So we can say like anagrams equals default dict, and each key will have a list of anagrams. So this will be list. Then for word in strings. So what we want to do is we want to break up the word into characters, sort the characters, make a word again, and use that as a key. You can't sort a string because a string is immutable. So you have to first break it up into an array. So you could just do this. So you could say like sorted word equals, so first we want to break it up. So this is just you can turn into a list. So like this. Then you want to sort it. So you can do this. You can make it a sorted list. And then you want to join that whole sorted list to make it a string again. So we can just join it like this. So we break it up into a list, we sort it, and then we return it. So now we have our key, and now for our key, we will put in this word into its list of anagrams. So we can say anagrams sorted word equals word. Finally, our output, so we're going to have a dictionary where we're going to have a key, which will be a sorted word, and then the values will be all of the anagrams for that key. So basically what we need is we just need to return the array of values. We don't really need the key. We need just every single array of anagrams. So we can return anagrams.values. So this will be the array of all of the arrays of anagrams that we have. I don't know why I still have this time. That's interesting. This is for another problem. Weird. Okay, and it looks like we have a problem. So let's see. So it looks like we're not joining. Let's see what we ended up doing here. Output is ATE and AT. Oh yeah, so we have this sorted word. Oh right, so we don't want it to equal word. We want to append it, right? Because this anagram sorted word needs to be a list of anagrams. So append. And the reason you use a default dict, which is nice, is if this key doesn't exist, it will default to an empty list. So hopefully that's correct. Okay, there we go. And you can see this is pretty efficient. The other way is actually slower because, like I said, these words are only 100 characters. So yes, it's linear time instead of n log n, but n log n for a small number is it's roughly the same as linear time. And making all the strings and all that stuff is actually going to be slower in practice. So this is going to be runtime of, so we have to sort every single word. So let's just say like the average length of a word is, call it like W or something. So it'll be like W log W for every single word. And then this is going to be the length of the word. So it'll be like W log W times N, something like this. But since every word is only 100 characters, that's fine. And yeah, I think that's mostly it. And then for the space, so for the space, obviously we have to have like the actual result that we're going to be returning, like this values we have to have. So the extras thing we're storing, we are storing all the sorted words. And worst case scenario, let's say every word is unique. Let's say there are no anagrams. This is basically going to be O of n times is the number of words times W, which is like the number of characters in each word or something like that. So it's going to be like n strings, and then W is going to be the character. So this will be the total number of characters stored. If you want the total number of words stored, it'll be like O of n or something like that. Yeah, I think it's going to be all for this one. Like I said, not too bad. And it is kind of cool to see the other solution. And yeah, like I think for tougher problems, you can easily make a problem where sorting will fail and then the other solution will pass, making that a string out of the dictionary values. If you just change these constraints up a bit, you make this value really big, and then you make it so you can't sort the words. But yeah, that's going to be all for this one. Hopefully you liked it. And if you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.